In this video we're going to look at quality management, in particular quality planning. So you'll recall this from previous videos. We've developed our work packages from our scope planning process. Then we do the time planning, we figure out the resources duration. And then once we'd figured out our resources, we could figure out how we were going to obtain those resources, procurement planning and resources planning. Now we're looking at the other side, where the work packages also have requirements. They have things that you have to do as part of those work packages in addition to doing the work itself. You have to make sure that it's being done to the right standards, quality planning. There might be some communications involved, there might be some safety issues, especially if you're doing construction work, and there might be environmental protection planning issues that need to be addressed as part of that work package. So what we're looking at today in this video is the quality planning issue. In the following video we'll look at communications. Safety and environmental we're not really looking at as part of this course. We looked at them in construction practices. But do remember that they're there. So what is quality? It's the degree to which the characteristics of a product, service or result fulfill the project requirements. In other words, what you're doing, have you actually done what you're supposed to do? In the consultancy project, it might be, have you produced the design that you're supposed to produce? In other words, the design that the client requires to meet all of the client requirements, and some of the requirements that the client might not even know he needs. With a construction project is, have you constructed it as per the construction documents and other requirements as well? Now it's important that you distinguish quality from grade. Grade is a category or rank to distinguish items, and the best way to show that is to take an example. So we've got a bracket here which is sort of holding up a beam on top of a column, and the metal bracket with the bolts is actually holding it all together. Now those brackets can be stainless steel or galvanized steel. Now galvanized steel is, as you can see, less expensive. It's half the price of the stainless steel, but galvanized steel is a lower grade product than stainless steel. Stainless steel is high grade, it's good for a wide range of environments, it doesn't rust, whereas galvanized steel, even though it's galvanized, could over time. So it comes down to the circumstances, the situation in which the product is being used. So if you had just normal use, say for a house inland or something like that, then a galvanized steel bracket would be a high quality product. It would meet the client requirements and it would be at a low cost. Whereas a stainless steel bracket would be, do the job, but you paid more than what you needed to pay for it. So it's not a high quality solution, it's probably more of a medium quality solution. However, if we had this in a marine environment or close to a marine environment, then the galvanized bracket would be a low quality option because it's medium grade. It's not going to survive in that environment for very long. It's not going to do its job of holding this structure together for the time period that it's required to, whereas the stainless steel bracket would. So in that situation, it is a good quality decision to actually use the stainless steel bracket. So quality depends on the situation. Grade is the nature of the material or the workmanship that you are sort of talking about there. So let's look at construction quality. So for a construction project, generally it means you've completed the works to the contract document, but there's a little bit more to that. So that's what this shows, that the contract document has most of the stuff that you need to know, the boxes you need to tick to meet the quality requirements. So in particular, the drawings and the specifications. The drawings show you where everything's supposed to be, and it's supposed to be there. If it shows that a road is in a particular location, it might be okay to have it 5 or 6 mils, left or right of it, but 1 or 2 meters is a disaster. So the drawings show you where everything's supposed to go, how thick things are, all that sort of business. And the specifications describe the materials and the workmanship. the grading curve for the aggregate that you're using for a road, the treatment of wood that you're supposed to use for it, all those sort of things. And related to the specifications would be standards. So outside of that, they might just refer to a New Zealand standard for, say, wood treatment, and that is also the wood that's used has to meet that standard as well. And there are codes of practice if you are working within a council environment, or the organisation, if you're working on a state highway, they'll have codes of practice. There is your own company quality system, the way you do things. On the other side, we've got the consent conditions. So outside of the contract document, or the contract document might just say you have to meet the consent conditions. So you might have to do inspections of, say, erosion and sediment control systems. You might have to have a building inspector come out and do inspections and sort of tick it all off. Laws and regulations, that would come down to safety, but also the quality. So there are quality standards for what we build, and the stakeholder requirements, and that could be the client requirements. Are you actually doing the works as the client requires? It could also be neighbours. You might have noise constraints. So quality could be that you are doing the work within the required noise restrictions. So you can see that the contract document is the principal quality reference, if you like, but there are these other things that you also need to consider when you're doing a construction project. A design project, or any type of consultancy project, much the same. You've got consent conditions, laws and regulations, but with a consultancy project you are less sure about what the client wants. So you've got the client brief, you've got the consultancy agreement. Remember, we sort of talked about those when we looked at initiation. That's when you agree with the client what the scope of services is and what the product is going to be. And then stakeholder requirements. So that would include the client requirements, but it would also include the requirements of future users, of the consenting authorities, all those sort of things. So these things here all happen in that scoping, that scope planning side of things, when you're trying to figure out exactly what you're supposed to produce, because you can't really meet the client requirements if you don't know what they are. And that's what these three are all about, is what are the client requirements. You've got guidelines and standards. The client might have organisational standards. So for example, if you're doing a state highway, the NZTA, New Zealand Transport Agency, they have their own set of standards, and they tell you how they want a road built. Okay, so you need to refer to those if you're designing a state highway. There are industry codes of practice. They will tell you how you should design a road. So there's the standards that the council use and things like that. Your own organisation's quality systems, how you do things. It might be that you want to exceed the client requirements, and that's maybe a decision that your company's made. And then there's consent conditions and laws and regulations. So you can see that quality, there are a lot of things that are inputting into what is quality. What are the things that you need, the boxes you need to tick to make sure that you are meeting quality requirements for your project. So, quality management is the policies, objectives, responsibilities that are implemented so that the project will satisfy the needs for which it is undertaken. In other words, meeting those requirements that we talked about just before. And there's three, PMBOK has three quality processes. So the first one is plan quality management. So right at the start, you plan what you're going to do. That's not a static thing. You will be upgrading that plan as you go through the project. Executing is you perform quality assurance. In other words, you go out and you do the inspections, you do the testing, and you document it. So performing quality assurance is not just doing the testing, it is documenting it and having those documents in a form and a place that they can be checked by others. So quality is not just about achieving quality, it is also demonstrating that you have achieved quality. And the last one there is control quality. In other words, you take those inspection and test results and you compare them to the specifications or the client requirements or whatever, and you determine, are we actually achieving our quality objectives? Are we actually going to produce what we're supposed to produce? So that's what the quality control is all about. So those three sort of act together in a sequence, but also together. So what we're going to look at today is just the plan quality management. We'll look at the perform and the control quality later on. So quality management principles underlying it all. Customer and stakeholder satisfaction is project success. If you can produce what these people are asking for, then you're most of the way through to having project success. That's not to say that that guarantees it, but it's a pretty good step towards it. Now this one here is very important. Prevention over inspection. It is cheaper to prevent a bad thing happening or a quality non-compliance happening than it is to find it by inspection. For example, concrete arrives on site. If you test it before it is laid and you find that it's defective, then you can send it back to the factory. However, preventing it, what you can do is make sure that the concrete that arrives on site is going to be okay. So you would hire a certified concrete supplier that you are confident will be able to supply the right concrete. You will test it, okay, but it's unlikely that the concrete that arrives on site is wrong. So what you want to do is you want to prevent non-compliance happening. That includes training, making sure that the people that are doing your work in your organization are trained and qualified to do the work, so that they're not going to make mistakes. They know what they're doing and they're not going to make mistakes. Rather than looking at their work and saying, oh, that wasn't done right, rip it out, do it again, because that is really expensive. You've picked up the non-compliance, but now you're going to lose time and money in fixing the mistake. It's better that the mistake never happened in the first place. Plan, do, check process. Now we're going to talk about this in the next slide. It leads to continuous improvement. So it's not just a matter of saying, oh, we did that one okay, well done, hopefully we'll get it right next time. It is continually improving the systems and skills and the way your company does stuff. That is how you improve as a contractor or as a consultant or individually as an engineer. You should always be learning, looking at what you've done, looking at it critically and saying, have I done really well? What can I do better next time? Just staying static means that you don't improve. Quality management is a subset of risk management. So risk management is all about what are our project objectives, what are the things that can stop us from doing it, and how can we prevent those things happening, but if they do happen, how can we reduce the likelihood? So quality management is that. It is that objective of we want to produce what we produce needs to meet the project requirements, and one of the risks is that we don't do that, and so quality management is really just a risk management process. The same as safety management is, which is to make sure that we do everything safely, and environmental protection management, which is that we want to do it without damaging the environment. They are all subsets of the risk management process. And the cost of quality management needs to be compared to the cost of quality failure. You could spend millions upon millions upon millions of dollars. You could spend up all your profit on doing checks and stuff like that. That has to be, and then you wouldn't make much profit. So the processes you put in place to ensure quality, you need to balance those against how much they actually cost, and we'll look at that in a slide in a minute. So now let's look at that plan, do, check process. So this is the classic quality. It can be used for management in general, but it was originally developed by Deming, who was the sort of the father of modern quality management. And this is how a company gets better and better and better at what it does. And if you want an example of how effective this is, look at Japan. It sort of started off as a middling industrial country, and now its industry is among the best in the world because they adopted quality management system. And so plan is establish the objectives. What do you need to what do you need to deliver? How are you going to deliver it? How are you going to make sure that it's delivered properly? You do it. You implement the system. You check. You make sure, have we actually achieved our objectives, and could we do better? And if you could do better, then you act, you improve the way you do stuff. So it might be that you say, okay, well, it took us a bit longer to do that curb and channel, or we didn't quite get that road laid right first time. We're going to send those guys off to do some training. Or the concrete was late in arriving, we're going to use a different concrete supplier next time. Or we need to train up more caddies or something like that, or they need to learn to use 12D, whatever. So you're always looking at how can we improve the way we do stuff, not just the standards of what you produce, but also the efficiency of how you do the work. So the cost of quality, you don't have an unlimited budget. You need to balance the cost of conforming versus the cost of failure. So the cost of conforming is the prevention work, the training with people, researching, documenting it, getting testing equipment, doing the testing, doing the inspections, maybe hiring other people to sort of do it. So that's all costs. Now, I haven't shown it in the diagram before, but you need to include those costs in your budget. They are things that you actually have to pay for. But you could spend, all your profit on doing all this. So you need to balance that against the cost of failure. And the costs of failure are internal work. If you do something wrong, you're going to have to rip it out, do it again. So rework and wastage. And then external failure. So there would be the liability. If you don't build it right, the clients, you may run over time and have liquidated damages. And there's your reputation as well. The client looks at that and says, look at these bunnies, they totally mucked up that road, they had to rebuild it, I'm not going to hire them again. So you need to balance those two things there, and get a balance where you are actually achieving your quality objectives at a reasonable price, but you're not going to be able to cover everything off, so you need to keep that in mind. ISO 9000 is a series of standards for quality management systems, and an organization can decide to become ISO 9000, I think it's more like ISO 9001, or registered, certified. And that is something they say to clients, look, we are ISO 9000 registered, and they say, well, that demonstrates that you have a quality system in place that's actually going to do the job. So now let's look at planning quality management. You identify the project quality requirements, you document how the compliance will be demonstrated. So you've got the work packages, so for each work package there should be part of the quality plan. You've got the requirements documents, which is the contract document or the industry codes and standards. You've got your previous experience. So you don't just start from scratch. You say, well, last time we did it, what quality checks did we do to make sure of it? Most companies have templates and checklists when they're doing stuff. So you do the quality analysis and analyze how much it actually costs to do it, and you come up with your project quality plan. So you're doing that, comparing the cost of failure against the cost of compliance exercise as well. Okay, and so for a construction project, you got all the standards there. So this is coming out of the drawings, this is coming out of the standards, and they all come to it. So just something like a pipeline, you've got all these things to consider. Is the pipeline in the right place? Is it the right type of material? Is there right spacing between them? Have they got the right bedding underneath? Are they at the right level? So all those things there need to be checked and documented. And the way you document it is with this thing here, the construction quality plan, also known as an inspection and testing plan, an ITP, in the construction industry. So it's got the activity, the check, what are you going to check? So this is a work package. So the work package is, have we got the pipeline in the right place? We check that with surveying. When do we do it? Or how often do we do it? Who's responsible? And so the idea of this is that at the end of it, we've got a checklist, a to-do list for the people on site. So the project manager for the pipe welds needs to know that he needs to be checking all these things and producing documentation for it. So most companies will have documentation that they fill in. So it's really quite important that quality is done properly. If it doesn't done properly, it'll run over time, you'll lose reputation, and it'll cost more. So it is quite important that quality is considered and properly planned.